All right. Yeah, so as mentioned, my presentation is on ETH data, harvesting the value of the Ethereum ecosystem. First, this is me. As mentioned, my name is Ben. I'm a senior protocol specialist at Figment, covering the Ethereum ecosystem. For folks that aren't aware of Figment, we're a staking service provider. We offer infrastructure on like 3 to 4 dozen networks. We also do a lot of work with data, hence the presentation. I've ripped off a lot of people in this presentation, so please feel free to reach out. If there's anything here that interests you, I'm happy to share the source with you. It should provide a lot of information for you. Benjamin@figment.io is the best way to reach out. If you like Twitter better, builder_Benny is my handle. I'm a taker on Twitter, though I don't really post a lot. So if you want to communicate through Twitter, feel free, but I'm not very active. So I'm going to get into the agenda in a second. But from a high level, this is just meant to be kind of like a skeleton or like a structure to look at indexing data. So I'm going to give you kind of the high level of indexing data, and I'm going to scratch the surface on a few things because I do have a limited amount of time. And then if you're interested, as I say, feel free to follow up, and I can provide, there are lots of useful presentations out there that'll give you the meat to the structure that I have here. So, nope, sorry, not yet. So first I'm going to cover the challenge with blockchain data. Should I be using a mic instead? Okay. 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 Is that okay? Okay. So first I'm going to talk about the challenges with blockchain data and why it needs to be indexed. Then I'm going to talk about when it is indexed, what you can do with it, some of the applications and use cases. And then finally I'm going to talk about future directions. So even if you were standing where I was, I know you probably can't see this even in the first row, but even if you were standing here, this is a block from Ethereum, not overly readable. What you have here, I took a block from Infra on Ethereum, and basically what you have are hashes of transactions, so basically hexadecimal, representing all the transactions in a block. There is some readable stuff here, but it's almost all hexadecimal. So this is one of the key problems with blockchain data. It's not very readable when you look at it. The other part is, of course, data on the blockchain. Oh, different mic? It's okay. Okay. Okay, there we go. Okay, strong start. The other part is, of course, data on a blockchain does have structure, but it's structured to serve the blockchain, not to serve analytics or people that would like to infer things about it. So what you want, the other key part about indexing data is if you want to query, do a lot of queries, do lots of analytics, it's way too time consuming. Like if you wanted to find out, if you want to take an address on Ethereum and see all the transactions it's ever done, that would take a really, really long time to query directly from the blockchain. So those are the two key reasons why indexing is important. And so of course here we are with indexing. 3 broad steps here. There's extraction, there's transformation, and then there's storage of data. And here you have a diagram taken from our data team at Figment. This is for Solana, not Ethereum, but basically the same 3 broad buckets apply. Here you have a node on Solana, and of course this represents the extraction or ingestion of the data. This middle part, of course, is transformation, and then it ends up in a database. And then obviously the database can feed all kinds of things: internal reports, reports to customers, all sorts of other things. Before I go into indexing a little bit more, one of the things obviously to note is that the Ethereum ecosystem is massive. So I mentioned a block from Infra. Obviously that's coming from the execution layer. You also have the consensus layer. So if you're interested in validator data, so like consensus layer rewards, execution layer rewards are on the execution layer, of course, but consensus layer rewards for validators are obviously on the consensus layer. But beyond the base layer of Ethereum, obviously you have MEV boost. That's another source of data. So if you're interested in relays and MEV and things like that, you're going to need a connection to MEV boost. You also have L2s, of course, as mentioned in the prior presentation. The point is there's tons and tons and tons of data that could be indexed, and there's lots of value in that data. So if you are interested in data on Ethereum, you have to have a decent sense of what you're after. And the other thing is, too, you need to bear in mind that, as I mentioned already, stuff that's coming from the base layer often needs a lot of transformation. And there's other stuff on the ecosystem that doesn't need as much, and I'll get into that in a little bit. Okay, so again, broad steps in setting up an indexer. The first thing, and I would say this is probably the most, it's not really a difficult step, but the most difficult step, if you're starting out, is access to raw data. So to access the raw data, you need a node and you need tools. So a node you can run yourself, or you can use a provider. I mentioned Infra. There are lots of other ones. There's Alchemy, there's Quick Nodes. There's a whole bunch of them. And there are trade-offs. So if you are going to run your own node, you have to think about how far back in Ethereum's history do you want to go. If you want to go back to the start of Ethereum, you need an archive node. If you're happy starting today and rolling things forward, then you can get away with a full node. And that decision isn't actually arbitrary. It turns out there's a 10x factor in terms of the storage you need if you're going to use an archive node on Ethereum, if you're going to spin up an archive node. You can also use, if you're just kind of dipping your toe in, you can use a provider like Infra, but you're even more rate limited with that, especially with a free account. Obviously, there are other tiers. You can have a paid subscription. And the other thing too with providers is that the endpoints are limited. So if you run your own node, you're not limited in any way. You can pull whatever data you'd like. But if you're using a provider, you will often be limited to what you can actually extract from the blockchain. I mentioned data transformation and storage. Those are pretty straightforward. One thing, though, as I mentioned with data transformation, if you're not pulling from the base layer of Ethereum, if you're pulling from a smart contract or an app built on top, oftentimes the raw data will be very intuitive. In other words, you can almost use it right away. Minimal transformation is needed in a lot of cases. So if you're looking at decentralized exchanges, for instance, you want to see the swap rate for, let's say, DAI to ETH on Uniswap versus Kyber or something like that. That's usually pretty intuitive. The only transformation you might have to make is going from text to an integer or text to a floating point or something like that. Storage as well, again, if you're dipping your toe in, you don't have to necessarily go straight to a database like Postgres or something like that. You can just send it when you're in a testing phase. You're just, again, just dipping your toe in. You can, like 2 lines of JavaScript, you'll be able to write to a text file or to a CSV. So if you're just starting out, I certainly recommend that. And then once you get a good handle on it and you want to scale up, then it's time to get a database involved. So here's something that people have likely seen, ETH Beacon node. So this is, refers to the consensus layer of Ethereum. It's on Ethereum's GitHub. You can test it out. You'll notice, I don't know if you can see it back there, server URL. If you do go to the website, don't do what I did, which is to try and use it as it is. You'll see, oops, I'll go forwards. So these are a bunch of endpoints that are available, categories of endpoints. And if you picked Beacon, for instance, can I get next slide? Sorry. There we go. You can get a bunch of different measures, so validators, validator balances, sync committees, stuff like that. But if you don't change that URL that you saw at the beginning is just a placeholder. You do need to put something there. Either you can connect to your own node, or you can use a provider. So on the next slide. So that's exactly what I did here. This is really simple. I used QuickNode. I don't believe Infra works with this one. This is for validator balances. So you can see the link here. And in fact, here as well. This is for QuickNodes. It took 2 minutes to set up a free account. They only give you one endpoint though, so again, choose your providers wisely. Next slide, please. And then here I just grabbed a validator index from Beacon Chain, the Consensus Layer Explorer. Next slide, please. And then you get the results, the balance here. So roughly 32 billion GUI, or about 32 ETH. Next slide, please. The other useful thing about the website, it'll give you the curl command here, as well as the requested URL. If you're comfortable with shell scripting, you could create a bash script and you could run through several examples this way. I think this type of thing, using curl in a shell script, is you're probably looking at tens of data points, if not maybe hundreds, if you don't want to do it manually. But if you need more than that, so if you want to extract data at scale, this is not going to work that well for you. Next slide, please. So for instance, at Figment, we do index all kinds of data on Ethereum. One example are consensus layer rewards. So folks that aren't as aware, the stuff over here, these are all the duties that a validator would perform in terms of attestations, proposals, and sync committee. These 3 here, timely head, timely target, timely source, that's all attestations. That just gives you a breakdown of the base reward and how it's split up for those duties. But those are all things that we index for. And as I mentioned, the quick walkthrough I just did, what we do at Figment is similar in concept, but we do it a little bit different. I won't go too much into the details here, but essentially what we do is we actually download or fetch the entire state, and then we look at the transition, and the deltas we capture. Okay, so what we actually do, there are these functions here. You can get them in Prism's docs. Prism is a consensus layer client. Everyone knows it's the biggest consensus layer client on Ethereum. So these functions here, we modified them slightly to get what we need, these pieces over here. And that's how we index on the consensus, for the consensus layer rewards. Next slide, please. So again, just scratching the surface at indexing rewards on Ethereum. What would you do with that? Why is that useful? Well, from our perspective as a staking service provider, there are all kinds of uses that we have for data, reward data in particular. Obviously, we want to evaluate performance. We use that internally. We use that to troubleshoot if we have any performance issues. We want to know how we're doing versus the network. Insights is another obvious one. Seems like a generic, silly thing to say, but actually it's not. We actually, one of the members on our data team found a weird outlier on Ethereum. So, and I don't know if you can see it back there, but essentially, if you're writing a validator on Ethereum and you want to exit, the flow is, I request to exit the active set. I have to wait a little bit. If there's an exit queue, I have to wait for the queue to finish. Then there's another 256 epoch delay, that's roughly a day. After that, I've gone from exited to withdrawable. My stake gets picked up in the withdrawal sweep and it's sent back to my account. So what the flow is supposed to look like is that after the 32 ETH leaves Beacon Chain, leaves the consensus layer, that's the end of it. So I don't know if you can see back there, but this line here for this validator, that's that line right there, 32 ETH. That's the stake leaving and going back to the account. This validator's done. What you shouldn't see is this line right here. There's a little tiny bit of ETH. And why that's weird is that technically what this is telling us is a really wonky edge case. What it's telling us is that Ethereum views this validator as having exited, but they still earn some rewards after. And it turns out what's happening here is this validator, along with another one that this person on the data team found, is that they requested to exit just after they were assigned to the sync committee. Sync committee is a period that lasts for 256 epochs. So again, roughly a day where you're doing something entirely different. You might have remembered it back in the prior chart. So what's interesting is that technically the validator's exited, but they're still performing duties on the consensus layer. It's a weird edge case. I don't think it's a huge security concern, but it is very interesting to note, something that we wouldn't have thought of. Next slide, please. I mentioned reporting before. We also have Fig app. It's like a self-serve staking tool for people that are kind of DIYers and want to do it themselves but use our backend to do it. That's what the Fig app is all about. Here's a print screen from that. My colleague Justin helped me out with this. Obviously, you can see his name there. But all kinds of things, not just Ethereum. You can see Solana as well. Over here, it's kind of hard to see, but you can see the activation queue, 22 days, and then withdrawal period. So all kinds of data feeds into stuff like this. Next slide, please. Here again, more dashboards that we use. This stuff, just general rewards. Here you have Ethereum rewards broken out by sync committee, attestations, and then execution layer rewards. Execution layer rewards, of course, are the very volatile series at the top. Here we have relay dominance. So if you've been following MEV, you know there's this competition in the relay space, and you can see how that's changed over time, the different colors, green, blue, and stuff. So you've got flash bots, block native, blocks route, stuff like that. And then up here, you also have rewards for the various validators. So all this stuff very useful for us to look at and make sure that we're performing in line. Next slide, please. So for folks that are interested in the Fig app, it's kind of hard to see at the top here, the link, but you can try it out. You don't have to actually put ETH on, you don't have to deposit mainnet ETH. I think we'll actually give you Gurley, but I'm not 100% on that. But if you're interested, you can check it out and you can see some of the analytics that we offer customers. Next slide, please. One of the other use cases, the last one I'll mention before I go on to the last piece, Market Vector. We partnered with Market Vector, TradFi asset management data firm, to create staking rate return or staking reward rate and total return indices. These are used by TradFi folks. So if you want to index things like staking ETF, if you want to do swaps fixed to floating that are related to staking, you would use these. So that's another important use case of data. Next slide, please. Okay, this is, I mentioned decentralized exchanges and MEV and stuff. This is something, we don't do this at Figment, this is just a hobby of mine. This is a simple JavaScript that will look at prices on 2 different decentralized exchanges. Very straightforward. I actually ripped this off of Eat the Blocks. So if you're interested, I can provide a link to that. You can see, you can get this stuff anywhere. MEV is very competitive, and it's open source. You can find this stuff anywhere. I'm not going to spend too much time because I think I'm kind of starting to bump up against my time limit here. But next slide. The one thing I'd point out for this, the JavaScript stuff is pretty straightforward. I think most folks that have that kind of, that they're developers or engineers can pick this up very easily. The one thing I would say though, if you are interested in this kind of stuff, if you are interested in monitoring different prices and looking at arbitrage on Ethereum, the key thing is going to be ABIs. So you want the ABIs for the different decentralized exchanges. That's what this line right here is. ABIs.kyber. If you could go to the next slide. Next slide. Kind of hard to make out, but here we have it right here, methods, get expected rate, and this is where the rate for wrapped ETH is being pulled in for Kyber. You have a similar one for Uniswap. And then, next slide, please. It's okay. So anyway, the point is, you should, if this interests you, you should go to each decentralized exchange's site. You can also go on Etherscan, and that's where a lot of you can get a lot of information on smart contracts, the ABIs, and how you call them and things like that. It's pretty straightforward. Next slide, please. Then here you can see this is the relevant one right here for what we were working on, iKyber network proxy. Next, please. Next. And then there you have, just so you can see it, get expected rate. But that's basically what you're looking for if you wanted to create a monitoring tool. Also in the ABIs, you're going to need to be able to execute if you do find an arbitrage opportunity. By the way, this is an academic interest. In my opinion, the MEV space is very, very crowded. It's not a place to make money for like hobbyists, but I have an academic interest in it, I'd say. So anyway, next slide, please. And next slide, sorry, I'm just gonna run one more. There we go. Here's the output. I mentioned just a text file. This is a good way to test things. So here you have the block number, and then you have the different cross rates. So you have a bid and ask on both Uniswap and Kyber. The idea is they have to cross each other for this to be a profitable arbitrage. The other thing is too, it's very basic. Basically the way the logic of the program works is that it waits for a new block and then it updates the prices. That's not very effective. You need to have something a little bit more timely than that, not every 12 seconds, probably every second or every half second. Next slide, please. So anyway, the point of the MEV stuff is really focus on the ABIs. That's the key part to building something like that. The JavaScript is easy. Anyone can figure that out. ABIs are the same thing, but you just have to do a little bit more work. So just closing off here, obviously if you have an interest in data on Ethereum, you'll have an idea about what you want to extract, what you want to index. But if you don't, if just the concept of data, blockchain data, and you want to get an interesting, valuable data set, some advice, ephemeral or off-chain data, mempool, lots of folks are doing this, especially in the arbitrage space. They're taking snapshots of the mempool. And I put mempools in parenthesis with an S for a couple of reasons. First of all, people refer to the mempool on Ethereum. There isn't the mempool. There's actually, it is in concept the same mempool, but depending on where you take snapshots, things are going to look a little bit different. If you took a snapshot here, it's going to look different than if you took a snapshot at the same time in Europe. It's going to look different than in North America, et cetera. The other thing is, what's really interesting here is, if any people have heard about account abstraction, if you haven't and you want to learn about it, highly recommend Matt Cutler of Block Native. He does a 20-minute talk, explains from a high level what account abstraction is. His takeaway though, and why this is so interesting, and this is I think a very, very interesting idea and very value-rich data, is that account abstraction is going to create multiple mempools. It's going to create multiple mempools, not of transactions, but of intents. Intents from a high level are more expressive than transactions. So I could say something like swap DAI for ETH. That's one intent. That's what I want out of this. Instead, on Ethereum today, it's actually more than one transaction. So not an expert on account abstraction, but the idea here is very interesting. Anyone building on anything in account abstraction, that is a valuable data set. And lots of folks, I think, would be interested to have snapshots of the mempool. So as account abstraction is starting now, if anyone's interested in creating valuable data sets, that's where I'd look. Who's building on account abstraction? And what kind of mempools do they have? What kind of intent pools, let's say, do they have? Very interesting. Two other things, and then I'll be done. Which relay is best? So again, I keep going back to MEV Boost, and a reminder, MEV Boost is this sidecar piece of technology that allows validators to sell block space to MEV searchers. They have to connect to relays. Relays, in turn, are connected to builders. They're connected upstream to searchers, private transaction pools, and of course, the mempool or mempools. It turns out, if you're trying to evaluate relays and you just want to know who has the best return, you'd think that would be easy to solve. It's actually not. It's not a trivial exercise. So this is actually a really good use of data, and it's a tricky problem. And I think if you could sort that out, if you could show and have that pool of data, that would be very valuable as well. Last thing to say, bringing clarity to the MEV market. You can see the theme here, MEV, a little bit. So ever since the merge, what's happened is we used to have geth-mev, which was searchers could send bundles to miners, and those bundles would be included in blocks, and you could very easily identify this is the MEV bundle. Today, the way it works is with MEV Boost, you don't get a bundle, you get an entire block. And it's not always clear how much of that block is MEV related. None of it could be, some of it could be, some of it could just be private transactions. So that's another interesting thing. There are some folks doing some good work here. Rated does a decent job. Also, I think it's EigenFi is tracking this, but that's another interesting use case. So the point of all this is there are lots of folks indexing data. The stuff that's on-chain, the stuff that's easy is interesting, and if that's what you're interested in, go for it. But if you're looking to create a valuable, rich data set that a lot of people are interested in, would highly recommend starting with a mempool and then look into account abstraction and get those intent mempools. Those are going to be very interesting in my opinion. That's all I've got.